At first glance, this looks like the perfect restoration project. An abandoned school bus, heavy corrosion, a forgotten interior, and the promise of an incredible before and after transformation. But this bus does not exist in the real world. It is a clearly disclosed AI-generated visual simulation created to answer a genuine question. Could a large vehicle damaged by saltwater ever be safely restored, or would the fresh paint simply hide a dangerous structure underneath? Before any attempt to start the engine, the first job would be safety. The batteries would need to be disconnected, the vehicle secured, and the maximum water level carefully documented. Trying to start a flooded engine could turn repairable damage into permanent mechanical failure. Water inside a cylinder cannot compress like air, and forcing the engine to rotate may damage internal components. Salt water creates a much more serious problem than ordinary rain. Salt remains inside seams, electrical connectors, frame cavities, and overlapping steel panels even after the surface appears dry. Combined with moisture, that residue can continue accelerating corrosion long after the bus has been removed from the flooded area. A professional assessment would therefore begin with a complete freshwater wash. The purpose would not be to make the vehicle look attractive. It would be to remove salt, mud, and debris so inspectors could see the actual condition underneath. Once cleaned, the bus would be lifted on a platform and inspected from below. The frame rails, crossmembers, suspension mounts, steering components, and spring hangers would be the most important areas. These parts carry the weight of the bus and absorb forces from braking, cornering, and uneven roads. Not all rust has the same meaning. Light surface corrosion can often be cleaned, treated, and protected. Thick scaling, deep pitting, or holes in structural steel are completely different. If corrosion has significantly reduced the thickness of a frame rail or weakened multiple suspension mounting points, the bus may no longer be a sensible restoration candidate. Removing the visible rust would not automatically restore the strength of the original steel. The remaining metal would need to be measured and compared with the correct specifications. The frame would also need to be checked for distortion. If its main structure is severely weakened across several areas, extensive fabrication or complete section replacement could cost more than the vehicle is worth. The electrical system creates another hidden challenge. A modern bus may contain long wiring harnesses, fuse boxes, lighting circuits, sensors, relays, and control modules. Saltwater can enter connectors through extremely small openings. Corrosion may then increase electrical resistance, create intermittent faults, or generate unwanted heat. Replacing only the visibly damaged connector would not necessarily solve the problem. Every harness section below the waterline would need careful inspection. In a serious saltwater flood, replacing major sections of the wiring system may be safer than attempting to clean hundreds of individual connections. The engine and transmission would also require more than a simple oil change. Before the engine was rotated, technicians would inspect the air intake, cylinders, fuel system, and exhaust for signs of water entry. Engine oil, transmission fluid, differential oil, power steering fluid, and fuel would all need to be checked for contamination. If water entered the engine, it might require removal and disassembly. Bearings, cylinder walls, piston rings, and internal surfaces can corrode while a vehicle sits unused. A part that looks clean from the outside may still be damaged internally. The transmission, differential, and wheel hubs would receive the same level of attention. Water can enter through vents and damaged seals. Contaminated lubricant may lose its ability to protect gears and bearings, creating damage that only becomes obvious after the vehicle returns to operation. Brakes are one area where shortcuts would be unacceptable. Steel brake lines, flexible hoses, wheel cylinders or calipers, air brake components, parking brake mechanisms, and anti-lock braking sensors would all require inspection. Any heavily corroded safety-critical part should be replaced rather than cosmetically cleaned. The steering and suspension would also need close examination. Spring hangers, shackles, steering linkages, bushings, shock mounts, and wheel bearings are constantly exposed underneath the vehicle. Severe corrosion in one of these areas could cause instability, even if the engine and body appeared fully restored. Inside the passenger compartment, The seats, wall panels, insulation, and flooring would likely need to be removed. Moisture and contaminated sediment can remain trapped under rubber flooring and inside insulation. Stripping the interior to the metal shell would reveal hidden floor corrosion and allow the vehicle to be properly cleaned and dried. Only after the frame and floor passed inspection would a genuine restoration plan make sense. The correct order would begin with electrical isolation and complete documentation. Next would come freshwater cleaning, fluid removal, and interior stripping. After that, the chassis would be measured, structural corrosion assessed, and a clear restore or scrap decision made. If the structure passed, damaged frame sections and body panels could be professionally repaired. The powertrain, brakes, steering, and suspension would then be rebuilt or replaced as required. New or verified wiring could be installed before the body was sealed, primed, and painted. The final stage would not simply be a dramatic reveal. The bus would require pressure testing, electrical testing, brake testing, steering alignment, and controlled road evaluation. A qualified inspection would be essential before it could safely carry passengers or be converted into another type of vehicle. And that leads to the financial question. A large bus may appear inexpensive when abandoned, but structural fabrication, a replacement wiring harness, brake components, powertrain rebuilding, glass, tires, and interior materials can quickly exceed the value of the completed vehicle. Converting the bus into a tiny home would not remove the need for a safe chassis. A beautiful interior cannot compensate for weakened frame rails underneath it. So, could this saltwater-damaged school bus be saved? If the exposure was brief, the water level remained low, and the primary frame structure retained its original strength, restoration might be technically possible. But in the severe conditions shown in this simulation, with widespread corrosion, contaminated systems, and possible structural loss, the responsible decision would probably be to use the vehicle only as a parts donor or recycle it. The most important lesson is simple. A restoration should never be judged by the shine of its final paint. The real decision is made underneath the vehicle, where safety, structure, and mechanical integrity cannot be hidden. This video used AI-generated visual reconstructions to explain a realistic restoration assessment. No real vehicle was physically restored. If you would like to see another abandoned vehicle examined through engineering and restoration logic, subscribe and tell us which vehicle should be investigated next.